Stars.
How are they classified?
Let's see.
Stars are classified by their spectrum, also known as the element they absorb, and their temperature.
The rainbow that we see is actually the spectrum produced by the sun, and it's different for different stars depending on their temperature. A cooler star will have a spectrum that has more red in it, while a hotter star be shifted up towards the blue end of the spectrum.
Stars classified as O and B are uncommon, but very bright.
And the stars classified as M are common. However, they are dim. The rest of the letters fall in between. O stars are blue, A stars are white, G stars are yellow, and M stars are red.
This is called the Harvard OM scale. This is the Hertzsprung-Russell diagram. It is a graph which plots stars' color, spectral type, or surface temperature versus its lumosity, which is its intrinsic brightness or absolute magnitude.
It presents three main types of stars. As stars begin to die, they become giants and supergiants. These stars have depleted their hydrogen supply and are very old. The core contracts as the outer layers expand. These stars will eventually explode, becoming a planetary nebula or supernova, depending on their mass. And then they become white dwarfs, neutron stars, or black holes.
Smaller stars, like our sun, eventually become faint white dwarfs, hot white dense stars. These hot, shrinking stars have depleted their nuclear fuels and will eventually become cold, dark, black dwarfs. Another method used to classify stars is the Yerkes luminosity classes, also called the MK scale. It is the work of the American astronomers W. W. Morgan and P. C. Keenan. It is based off the Harvard OM scale, which was previously mentioned, and a lumosity scale of grades Roman.
Thus the sun, a yellow dwarf star, is sometimes 5,800 K, is designated G2V, while a Barnard star, a red dwarf at some 8,100 K, is classified M5V, and the bright supergiant Rigel is classified as B8IA.
Luminosity is the total amount of energy that a star radiates each second, including all wavelengths of electromagnetic radiation.
In the Yerkes classification scheme, stars are assigned groups according to the width of their spectral lines. For a group of stars with the same temperatures, the luminosity class differentiates between their size, supergiants, giants, main-sequence stars, and subdwarfs. Here is a table.
Main-sequence stars are the central band of stars on the Hertzsprung-Russell diagram, and the youngest. These stars' energy come from nuclear fusion, as they convert hydrogen to helium. About 90% of them are main-sequence stars. For these stars, the hotter they are, the brighter they are. This sun is a
Dwarf stars are relatively small stars, up to 20 times larger than our sun and up to 20,000 times brighter. Our sun is a dwarf star.
Yellow dwarfs are small main-sequence stars. The sun is a yellow dwarf.
A red dwarf is a small, cool, very faint main-sequence star whose surface temperature is under 4,000 K. Red dwarfs are the most common type star. There are also giants and supergiant stars, basically old, large stars. There are red giants, blue giants, and supergiants.
A red giant is a relatively old star whose diameter is about 100 times bigger than it was originally and had become cooler. The surface temperature is below 6,500 K. They are frequently orange in color. Betelgeuse is a red giant. It is about 20 times as massive as the sun, about 14,000 times brighter than the sun, and about 600 light years away from Earth.
A blue giant is a huge, very hot blue star. It is a post-main sequence star that burns helium.
A supergiant is the largest known type of star. Some are almost as large as our entire solar system. Betelgeuse and Rigel are supergiants. These stars are rare. When supergiants die, they supernova and become black holes. There are also faint, virtually dead stars, white dwarfs, brown dwarfs, neutron stars, and pulsars.
A white dwarf is a small, very dense, hot star that is mostly made out of carbon. These faint stars were made after a red giant loosed its outer layers. Their nuclear cores are depleted. They are about the size of Earth, but tremendously heavier. They will eventually lose their heat and become a cold, dark, black dwarf. Our sun will someday turn into a white dwarf, and then a black dwarf. The companion of Sirius is a white dwarf.
A brown dwarf is a star whose mass is too small to have a nuclear fission occur at its core. The temperature and pressure at its core are insufficient for fusion. A brown dwarf is not very luminous.
A neutron star is a very small, superdense star which is composed mostly of tightly packed neutrons. It has a thin atmosphere of hydrogen. It has a diameter of about 5 to 10 miles. Also, binary stars. Double stars, binary stars, eclipsing binary, and X-ray binary stars.
A double star is two stars that appear close to one another in the sky.
Binary star is a system of two stars that rotate around a common center of mass. About half of all stars are in a group of at least two stars.
An eclipsing binary is two close stars that appear to be a single star varying in brightness. The variation in brightness is due to the stars periodically obscuring or enhancing one another.
X-ray binary stars are a special type of binary stars, in which one of the stars are collapsed into an object such as a white dwarf, neutron star, or a black hole. As matter is stripped from the normal star, it falls into the collapsed star producing X-rays.